Hi everyone, in this video I will talk about the difference between the gravitational potential energy, usually we call it potential energy, and kinetic energy. Both are energy that is related with mechanic, which is object that is moved, related with the movement of the object. And in grade 7 you learn about mechanical energy, in grade 8 we will focus to the thermal energy, and in grade 9 you will learn about electrical energy. Both are the type of energy, it's just the difference is only how they are used. Let's start with the gravitational potential energy. So as you can see in the simulation, the potential energy is shown as a blue color. See, if the dot is at the ground, there is no potential energy. But if I put the ground at some height, so I give some height, I put it higher, the potential energy will be increased. So potential energy is related with height. Okay, let's put it here. And then it's called as potential because potent, it's something that it's not seen yet. We cannot see what the energy do, but it has potential to do something. How to make this potential energy do something is by release this dot. See, when I release this dot, the potential energy is converted into another type of energy, which is kinetic energy. Kinetic energy is energy that is related with a movement. Object that has kinetic energy is object that is moved. So when this object, this dot is not moved, there is no kinetic energy, only potential energy. But when it releases, the potential energy is changed into kinetic energy. Let's slow it down. You can see that how at the bottom, all of the potential energy, the blue one, is changed into kinetic energy. So at the most bottom part of this slide, all of the potential energy is changed into kinetic. So this is in this part, this is the part when the dog moves the fastest. Here at the top, all the kinetic energy changes back into a height because now the dog. Okay, let's see the speed. What is the speed here? 1.2, 0.5, almost 0 meter per second. At the top of the slide, the speed is almost 0. It means the dog stop moving. There is no kinetic energy. All it have is potential energy. This is the ideal situation when there is no friction. So the dog will keep on moving, changing from potential, change into kinetic, and then change again into potential, and so on and so on. So that's the basic concept, the difference between kinetic and potential. Next, how to calculate the potential energy and kinetic energy. For the potential energy, of course, it will be related with height because the position of the dog, if you can see, at this height and at this height, the potential energy is different. So, how to calculate the potential energy? Okay, first we talk about the height, and then we can also change here the gravity. If I change the gravity like this, it also increase the, you can see the blue circle, the potential energy also increase. So gravity also relate with potential energy. If the gravity is very small, then the potential energy of the dog is also very small. Oops, it falls down. And mass also affect the the potential energy. Let's see. If I change the mass, it's small dots now, and big dot there, the potential energy is changed. So potential energy depend on three things: the mass, the gravity, and the height, the position of the dot. It's related with mass, gravity, and height. For the gravity, if we talk about Earth, the gravity usually we use 9.8 for the gravity acceleration. 9.8 meter per second square. So if let's say let's calculate, measure. Okay, let's see. Okay, there is a scatter girl here. The height is 5.87 meter. The position is 5.87 meter, and then the gravity is there 9.8, and the mass of the girl is 60 kilogram. Okay, let's calculate. Okay, first the height is 5.87, so the height is 5.87 meter. That's the height, and the mass of the girl is 60 kilogram here, 60 kilogram. So the mass is 60 kilogram times the gravity is 9.8, and the height tadi heightnya 5.87 meter. Okay, so mass times with gravity acceleration times with height. This calculation we can get 3, 4, 5, 6, 3, 4, 7 joule. Yeah, around this. Let's check the simulation. Okay, it almost maybe just because of the round off it's a bit different, but it's around 3451 joule. That's how to calculate the gravitational potential energy. What about the kinetic energy? Kinetic energy is related with the speed, the movement of the object, and the formula is this. So it's related with the movement, so it's related with the speed of the object. The faster the object moves, the bigger the kinetic energy. Let's say in this part, let's play it. Okay, this at this position, you can see at this position, the height is almost zero. The speed is at the top speed. The fastest position is at the bottom, 10.73 meter per second. So the speed is 10.73, so we just need to put into the formula. The mass is still the same, 60, and the speed is 10.73. 10.73 square. So make sure you square it into 2. Let's use calculator again. 10.73 times with the mass 60 divided by 2, we get 3453. Yeah, So as you can see that the energy is different because of the runoff. Like that should be in ideal condition the energy should be the same. So all the potential energy here will be converted to the kinetic energy here. So at the top the potential energy is 3 4 let's say 3 4 5 1, and the kinetic energy is 0. At the bottom it is the opposite. The kinetic energy is 3451 joule and the potential energy is 0. What about at the middle? At the middle, it means half will be for potential energy and half will be for kinetic energy. Let's check it out. See here, for example, this is the 5.8 meter, so 5 about 2.7 about here. Okay, let's see. Oops, it's too much. Ah, there you go. Exactly at the middle, the potential energy and the kinetic energy becomes half and half. So half is the kinetic energy because it has speed but still not the top speed, and it still has potential energy in half because the height is half of the top at the highest point from the highest point. Okay, that's for this video. Thank you for listening.